Hi there. AI is evolving rapidly, particularly in the fields of LLMs, large language models, and agentic AI. However, as we push the boundaries of what LLM agents can do, we reach a common roadblock. You see, it's not easy to connect one agent and a set of existing tools easily without using a common server. What if I told you there's an easy way to integrate your agents to your existing business tools or services? Using a project that I have built called the JD Agent, which is powered by Google ADK, Agent Development Kit, and MCP Model Context Protocol. I'm here to show you an example of how to integrate your agent with your list of existing tools and services using the MCP server. The MCP server acts as a standardization between your agent and your list of existing tools without writing external code for each of your agents and each of your tools.
This is the JD agent project we have built. So we begin things by writing the requirements.txt file. We should include Google ADK, MCP, python.env, and these two packages are optional. They are just for connecting a MySQL database and for the Google generative AI. It would be preferable if connected. Then you should create your environment variables in your .env file. This is the example of it, and you can go to Google Cloud and create your account, and then create a project and enable Vertex AI for your project. Then write your project ID and your preferred location. After which, go to Google Studio, Google API Studio, and you can generate your Google API key and then paste it here. And after this, we are good to go. So first, we'll begin by creating our virtual environment in our Python. In your terminal, write Python 3 minus m dot vn. We are creating our virtual environment dot vnv, and you can see it's been created. Now let's activate it. Source.vn bin slash activate, and you can see it's activated and it shows clearly. Now we can install all the packages in the requirements.txt to it. So pip install -r requirements.txt. So this will install all the requirements in our txt file to our Python in the virtual environment. In the meantime, we could talk about what is MCP. So as you know, every agent has many tools connected to it, but it is not directly integrated like how we would say agent is connected to the sub agents. Every tool has to be defined by the tool's specifications. Example, let's say I have a SQL database as one of the tools of the agent, or the other tool can be a Google Drive. So certain files has to be stored in the SQL DB. The agent has to write all the specified rules and specifications, and find and it must connect correctly with the SQL database based on its rules. Now the Google Drive connection rules might be different to it, so the agent or the developer has to write different rules to connect to each tools. Now this might be simple for one or two tools, but for organizations running multiple agents with multiple tools, uh, require a lot of additional running costs and development cycles. So to enhance this stage, MCP was developed by Anthropy. MCP is nothing but Model Context Protocol. It is a protocol just like HTTP or SMTP, and it is used to act as a standardization to connect your LLM agents to the different tools. So, what MCP allows is the sub tools available in the MCP. They follow the MCP protocol, saying that to access this tool, this endpoint will be available, and all the developer has to worry about is how the agent is connecting to the MCP protocol using the MCP tool set. So In cases where agent has to connect to multiple tools, MCP has been a standardized protocol. And to give you an analogy of this in a simpler way, just like how USB-C has standardized the port of the entire device system of the whole world, just like that MCP is acting. So in this diagram, you can see that, let's say I have an Android phone or a laptop, Windows laptop. All these devices are connected via USB-C, which acts as a universal port. So any the developer or the Android developer only needs to focus about how his app or his mobile phone works. He does not need to worry about what the other uh, companies or the other providers are acting based on it, because they will make sure that all their applications and services will be accessible via USB-C. So this is how MCP has acted. Now, this is the model context protocol GitHub page, the open source code, and in your servers, you can see that there are many servers which are available, uh, many services that are available. Example is Google Drive can be accessed as a tool, and it is built by MCP to be accessed by your agent. Similarly, SQLite, GitHub, and many more. So there are many third-party servers, many ranging from Alibaba Cloud Service for PostgreSQL. There is Apache here. Then there is AWS, Cloudflare, many from A to Z. There are plenty of services that are available in the MCP servers. So hope you understood what the MCP is. And in the meantime, yes, our dependencies are done. Now we can check if ADK is working or not by creating a test folder. So I'll create a test agent to check if the ADK is working or not. So for every ADK project or an LLM, we need a init file and a agent file. So your init will be from dot import agent. Oh, sorry. You can save that. And in your agent, it can be a simple agent. Uh, So this is the definition of usual Google ADK agents. I'll import Google ADK dot agents, import agent. Now you can see this yellow squiggle. It's saying that our uh, interpreter was not correctly installed, and yes, now it's gone. So just refreshing your interpreter might work it, and then import .env. Uh, and then load your env files. Then we create a root agent. So let me just finish this agent. This is a test agent, right? And I can show you what this agent is about. So yes, in our sample agent, we have a test agent which has a description. This is a medical agent, and this uses 2.0 Flash, and we have some instructions for it. Now let's run ADK web. This is the web UI version of ADK, and we can communicate with our agents through the ADK. And you can see we have our local host here. So let's go to our browser and paste the link. You can see your agent was selected. You can ask what can you do, and you can see the agent is running. Let it create a answer. And yes, it says I am a medical agent. I can suggest possible disease. So yes, ADK is working perfectly fine in our project. Now let's move on to the next one. So before we move forward, I would suggest you to install the SQLite viewer extension in VS Code if possible, because we'll be using SQLite for this demo, and the database can be easily seen in our IDE and stored visually. So that extension helps a lot. Now here you can create a new folder called DBs, and in your DB you can create a new file called createdb.py. This is a Python script that has the contents for all to create your database as well as all the tables in your database. Let me paste it because it will take a lot of time to write it down, but this is the code. You're importing OS and SQLite 3 because we'll be using SQLite. Then you're creating a database path. Since this database does not exist yet, we'll be creating this using this function. So we are writing db exist to a variable, and then you're creating a connection using a cursor AI. And then if the db does not exist, you're creating candidates table, uh, software development candidates table. So these are the tables which will be storing our resumes of the candidates, right? So they have the schema of the candidates table is ID, name, email, phone, current role, experience, skills, education, location, LinkedIn, and last updated. Now you can create, we are creating seven other tables, namely software development, IT services, banking, insurance, healthcare, travel, and real estate candidates. And we are creating a dummy table as well just for it. And then we are adding some dummy candidates data to the candidates table, the main table, just to see if it works or not. And then we are closing the connection, before which we are committing to the database. Now to call the create database function, we'll create name is equal to main. So to create the database, we'll go to our terminal and cd into our dbs folder, and then you can write python create db.py. So yes, we can see that the tables have been created, the data db has been created, and all these tables have been. Now you can go to candidates and you see the two dummy data, and then all the filled data accordingly. So yes, we have done our step one. Now our next step is to create our resume agent. So this project is divided into three parts. The first one is local MCP resume agent. The second one is the local MCP analyzer, and the third one is the JD agent. So this project is about the JD. JD stands for job description. The job description about a company can be given as an input to the final agent. So example of a job description for a software development company can be the title junior Python developer, description seeking a motivated junior Python developer, the small basics of a software field. So the first step for our project is creating the resume agent. His job or a role is to take in the resume in the form of a CSV file or in a table format, and then store it in the candidates table. So let's begin. We'll create a new folder called local MCP resume agent. And like I said, every agent has to have a init file, agent file, and additionally we'll be adding the prompt and the server.py. Now the init file is what, and then you're saving that. And you can go to your agent. Now the agent has to be built to access the MCP server. So this agent access the MCP tools, tool being the SQLite data database. So this is how the agent.py will look. Let me copy it. It's not easy to type it out so fast. So the agent, and I'll explain to you. Before we move on, just cd back to your root folder because the dbs is done. And yes, you can close that. Now this is your agent file. You're importing the path, and also you're importing your LLM agent. The LLM agent being to analyze your input data, whether it's a CSV or the query the tools or something. So all those things will be written in our prompt. Then the most important one is the MCP tool set. So this agent is using the MCP tools to access our database, and we'll be writing the prompt in db mcp prompt in our prompt.py, and then we'll be writing all our tools in the server.py. This is the line to access the server.py. And then in your agent you have your model name and instruction, and the new thing here is tools. So in your tools you're writing your mcp tool set, which has connection parameters as well as server parameters, and they are connected via the command Python because our project is built using Python, so we are sticking to it. The other options are using a UV file or a Docker file, right? And then you're giving the arguments as your server.py file. So let's also write the prompt for this agent. So this is how the prompt will be looking. I'll just show you how it looks. Yes. So the prompt says you're a highly proactive assistant for interacting with the local SQLite database, and your primary goal is to fulfill the user request. Now, these are the tools that will be listed. We'll have the list DB tables as well as querying the DB table. But the most important tool for this agent is insert data from a CSV file. So we'll be storing the resumes in a CSV file. Uh, and we'll be importing that CSV file into the candidates table. So we'll see that in action. Let's also write a server.py, and since this is also quite big, I'll copy and show you what it does. So your server.py has your MCP connections, and we have our logging set up here. So it will be storing in the MCP server log activity, which will be shown here. And then you're creating the path to your database, and then you're connecting your database. This is not a tool, but we'll be using that. The list of tools comes here. These are the tools your resume agent will be using. One will be list the DD tables, the table schema, querying the DB table, inserting the data, updating the data, deleting the data, and inserting data from a CSV, right? So let's go step by step. List DB tables, just as the name says. If you ask what all tables can I access, it will return all the tables that have been listed in our DB, and it uses basic SQL style query. Select name from SQL master where type table is equal to table, and we are writing that in a try catch block, and you are giving a connection using cursor, just like what we have done for creating the table creating the database. Similarly, we are using another tool called get table schema. This is just a prototype tool. It's not necessarily used by our agent, but just for the table definition we are just creating it. Then we have implemented query the DB table, just as the name says. We give the table name to it. Let's say I say list the candidates of candidates table. It will run this query the DB table, and it also has a select columns from table name. Now insert data. you can give new data to the table and it will insert it. Update data, you can give a primary key as well as the things to update in that table. Same way, delete table. Now the most important tool being insert data from a CSV file. So it requires two things, CSV content as well as the table name, and it will return it in the form of a dictionary, right? So we are creating the connection and returning the rows, and this is where we are done the tools. So just save them, and these three functions run as your MCP tool connection to your agent table. So yes, we have done it. Let's save our file and let's run our agent. So ADK web, and you can go.
So we are listing the tables in the DB and let it run. After which we'll be planning to add the CSV content to the candidates table, and I'll be wait before that I'll delete all the contents of candidates table, and that will run that query. So in the previous query we have seen list db tables and it has listed all of it. Now we'll delete it, and after which we'll add the CSV content to candidates table. So I'll import my CSV file and we'll press enter. Here you have seen the delete data query. So these are all tools. If you click on that, you will see. So yes, I rerun it again, and this is the insert data from the CSV. So now in our tables, when we refresh it, we will see that all the 20 candidates have been uploaded. So that was part 1, which is the resume agent. So this is how basic structure of the MCP protocol is enabled in a agent. Now let's build our other agents as well. So our second agent was the local MCP analyzer, and one sec, and the other one was JD MCP agent. No, JD agent. Let's call it test for testing sake. And in our analyzer, we'll be needing an init.py, and then agent.py. So the second agent analyzer, his job is to analyze the candidates table, filter out what all skills that person has, and classify or categorize those resume candidates into their respective tables. So if we go to our DB, all these 20 candidates will be classified into these 7 categories. So let's write the code for it. I will just copy it because it's not worthwhile to type it out. So I've written this before, and this is the init. It's simple. The agents remains the same, the only difference being that your name is different, and this is the MCP analyzer. So we have not written the prompt.py, and also we'll be needing a server.py, the same as before, just the tools and the prompts change. So in our prompts, you'll see that we print it. Our prompt focuses mainly on categorizing them into these 7 categories. So we first query the DB table, then we classify and transfer the candidates, and these are the 2 main tools. These will be defined in the server.py, and I'll show you that. So I'll just save this. We have the call tool, and here we come to the tools, classify and transfer candidates. This is an asynchronous function. It takes in the table candidates table and classifies them based on their skills, the other being query db table. And let's save this. And one sec, this has a issue, so yes, and let's save that file and make sure all the files are saved. Then you can run ADK web. Now this agent technically need not be run via Google ADK and can be run via the Python script alone, but this is a visual demonstration, so we'll be doing using, so we can write classify the contents of candidates table table into their respective tables. So you can see it's running. Yes, it has queried the DB table. So I've written the prompt in a way that it first queries the DB table, which will call the candidates table, and now it will classify and store them. Now this can run into an error in the visual part stating that the agent ran into a timeout error, but you can see in the terminal that it's the background is still running. And if you go to your database, and let's say if I press banking and if I refresh it, these candidates have been same way for real estate, for software, all these candidates have been categorized. This is why I told this agent need not be run by ADK web, because this is a tool to be run by the server in the backend. The users need not know how the candidates are categorized based on the skills. It automatically does so. So that's part 2 of our agent. It was similar to our resume agent by the functions. The only function different being classify and analyze, which will just take the skills or the current role sections of the table and categorize those candidates. So now we have all the 7 candidates filled. Let's focus on our main agent, the third agent, which will be our JD agent. The JD agent takes in the JD, job description of a company, analyzes it and checks which field does the JD come under. Then it will query into that particular field and rank all the candidates in the correct order of the JD requirements. So let's start with it. This also has an init.py. We'll run this here, and it has an agent.py as well as a prompt.py. We'll talk about it. So in our folders, we can see, I'll just show you, this is the JD agent. So we'll be using a agent sub-agent format here, and this is how we'll be using Control V. So yes, it will run into errors. Just I'll explain to you why we are using this method. So let's define the prompt, and hopefully just explain the prompt to you. So this agent has many sub agents under it. We'll create a folder called sub agents sub agents right now with the semicolon, and this sub agents will have all the other agents and a sub agent coordinator. So let's copy all of those and paste it in our sub agents. Yeah, paste. So we have our 7 categories and a coordinator for it. So the coordinator, will delete the PyCache because it's not needed. The init file of the subagent coordinator calls the subagent coordinator in the agent, and he has all the other services listed among him, and they act as his subagents. Okay, and then here's the prompt of subagent coordinator. He gets the JD question that's delegated to him. It analyzes it and decides which table to call. So if it's a software related JD, he will call the software development agent, and it will pass the JD to that particular agent, right? So now let's look into a demo of a software agent, and we have an init file and the agent. So this agent uses tools, the tools being accessing the DB, because we have to access the software candidates for this agent in this case, and then rank them based on the JD. So here is the prompt of the agent, similarly for all of them. So I'll just make sure all their PyCaches are deleted, because then the code might not run efficiently. So I'll just make sure that's done. Now in the meantime, I can close this ADK because it's not needed to run them. Make sure all the files are saved, and this is my final. Now we are having all these sub agents and the sub agent coordinator. Now we are missing a server.py, so I'll just copy that and paste it to our sub agents. So this server.py acts as the server tool section for all the tools that will be provided to it. Basically, the tool we would be needing here is accessing the DB and querying the table, the respective table. The table will be decided by each of these agents, and to decide which agent to call, the sub-agent coordinator is applied. Now this main agent.py, if he gets, so I'll just run this. Okay, it's saved. So the main agent, he'll call the sub agent coordinator if it's a JD question, and if it's not, he answers it on his own. So once this saved, let's run ADK web and see if our code is running well. Okay, so let's go to our code. So our candidates table is filled, and all our sub tables are also filled with their respective candidates. So let me ask, what can you do? And he will list what can he do, or his prompt will be, so we can see here he's transferring it to the sub agent coordinator, and he says I am a coordinator for JD. So now let's ask him some JD questions. So I have listed some JD questions in my Google, and if I go here, I have some JD of different. So let's say for a software development, this is a sample JD, right? So I can ask him, I have a JD, what do you do? So the root agent takes in the JD, he transfers it to the sub agent coordinator, and he says they are from the software development candidates. So he'll query the software development candidates table, and you can see this, and he'll rank them. Now these are the 5 candidates, and you can see that they were from the software candidates table: Tina Green, Alice Johnson, Frank White, Ivy Chen. All these people have been mentioned here, and you can see for that particular JD, Tina Green was the best choice because she has relevant skills as Python and SQL in her skills, and the justification for why she was chosen over the others. And why Ivy Chen was the least ranked, because she does not have the requirements such as Python, web frameworks and databases. Neither of them, so skills and experience were not. So you must be saying that this works perfectly fine. Let's do a demo of a JD for another agent as well. Just make sure it's just not for that. So let's take healthcare. It's a bit too small, but still, let's see. So let us first analyze how many candidates are there in health. So there are 3. Let's see how the agent ranks them up. So it has transferred it. Okay, I'll show you how the agent is communicating with the tools using a visual over here. So he has found that it's a healthcare agent, so he has passed it, and the healthcare agent is calling the candidates table. As we can see, these are the 3 candidates and they are ranked accordingly, and there is a justification for it. Okay, this was for the software development question. So we can see that the JD agent was calling the sub-agent coordinator who called the software, and you can see these robot are the sub-agents or agents technically, and the spanner-like tools are the tools. So this agent is using this, and all these agents are connected to the tools. This is done through the common server.py, and this is how the JD agent is using MCP tools. Not only our JD agent, all our 3 agents which we mentioned for our JD agent project has been using MCP tools to connect to an SQLite database. And it has been a wonderful experience sharing my project with you all. If you have any questions, share them in the comments section. I would like to answer them, and I will be happy to do so. Thank you.